All right, hey guys, and welcome back to another video. I know it's been quite a little bit since I last posted. However, we're just busy with a lot of different projects as well as a lot of other things going on in my life. However, I'm not going to bore you with that. In this video, I'm going to be going over a recent project that I completed for a client, which is a full stack AI retrieval augmented generation project. But this project really pushed my technical capabilities to the limit. I had to figure out a lot of things, and I'll break down everything in this video as far as what I did, what I took away from it, and the lessons I learned. So without further ado, let's go ahead and jump into the computer. However, before we go there, I just want to say if you find this video useful in any way, or if it helps you with your projects, please do go ahead and leave a like. It helps the YouTube algorithm. And if you have any suggestions for any other future videos, please go ahead and leave a comment down below. So here we are on the computer, and basically before we get into the actual details on how I actually went about building it and the problems and challenges I faced, I just want to explain the scope of the project and then show you the actual project itself. So essentially what this client wanted to do is they wanted to create a chatbot with retrieval augmented generation for a large number of PDFs. Essentially these PDFs were based in the medical field and had to do with a medical system. However, they had thousands of pages and they had a lot of unstructured data. So these PDFs were very, very large and they had a lot of tables, meaning you couldn't easily chunk the context and the text in the PDF into vectors. And so that's really the challenge with this project, was doing that. And so they had thousands of pages. It was over 40 PDFs. And the idea was to convert this into a chatbot product that he could use as a proof of concept. So essentially, I'm going to have to blur out a lot of this, but here is the front end that I designed. I will probably blur out pretty much all of it, but it's a basic front end using React. It has both the login functionality and registering functionality. So what I'll do is just log into the account and show you what the actual product does without really revealing too much details, since it's just a proof of concept. So once you log in, it takes you to this page with a simple chat UI window. The basic idea of the project is you can chat with the bot, and you can basically ask any question from those PDFs and it will retrieve an answer and run it through GPT 3.5 and come back with a response. And you can have basically like a chatgpt style interface to go ahead and talk to those PDFs. Also in the project, I built out a very simple admin dashboard since the client wanted to track the average questions asked per user, as well as the average time spent per user, and a ability to view all of the details on every single chat session that happened for a specific date. So that is a very quick overview of the entire project. Again, I can't share too much details, but hopefully that gave you an idea of what I did. However, we'll break down the technical aspects of it on here. So yeah, essentially that was the goal. And for the AI functionality, the problem that I was having, or the problem that a lot of people have, is that most parsing of PDFs into a vector database does not support unstructured data, such as tables, pictures, and diagrams, especially pictures and diagrams. So the reason for this is that when you chunk a PDF, it basically looks for very easy ways to chunk context. And so it'll look at something like the white spaces on a PDF. And if you structure your PDF in a clean format, it can easily do that and convert it into a vector database. However, when you have a table, the data is all over the place. And a lot of these parsers really don't have the ability to understand that like the thing over here on this table equates to this thing over here. And so that's kind of the hard part with unstructured data. So a lot of the project was really spent finding a good solution for a framework that allowed to convert those PDFs into a proper vector store. So if you kind of look into like doing retrieval augmented generation with semi-structured data or unstructured data, you would quickly find that they use this library called unstructured, which is an open source library to basically read this data. And then they will basically follow this process of converting the documents into tables and then text chunks, having a text chunk with the table summary in a separate store called the doc store, and then a vector database of the actual document text, and then using those in combination in a multi-vector retriever to then go ahead and get your queries. So I tried that and that pretty much worked. However, the problem was that LangChain retrievers use an in-memory store, basically meaning that the data on the tables after it was parsed could not be saved into a persistent database, which meant that like every time you start up the system, you would need to reparse the data and load it into memory, which obviously wouldn't work for 40 PDFs and really does not fit this use case. And so the hard part was really finding something to fix this problem and to save all that table data into some sort of persistent database, and then also have some sort of multi-vector retriever to go ahead and grab all that data. Now, that's a lot of technical terms, but essentially the solution that I found was this YouTube video by these guys here. And what they essentially talk about is R.A.G for complex PDFs. And they use a library known as Llama index. and the unstructured element node parser. And what this allows you to do is essentially take your PDF, convert it into an HTML file, allow the unstructured element node parser to go ahead and read through that HTML file and correctly map the tables. And then you can put that into a persistent vector database like Pinecone or whatever. And so I'd highly recommend for anyone that actually wants to implement this themselves. This video does a really great job, and I'll probably link it in the description. It's just called R.A.G for Complex PDF by AI Makerspace. Highly recommend them. They have a Jupyter notebook that goes over everything in this process. So yeah, that was arguably the hardest part, was then converting all those 40 PDFs, following the method, and then making sure that all that gets uploaded to Pinecone as a vector database, and everything works properly. So once the AI functionality portion was taken care of, it was now time to actually do the full stack portion, which was the front end and the back end. So essentially, this is a tech stack that I use right here. For front end, I use React.js and Tailwind CSS to make a very simple UI. For a database, for user data, and for chat context, I use SQLite locally on a Flask server. For the vector database, to store all the information that I generated using this, I use Pinecone. For the backend, I use Flask to run both the connections to the database, the SQLite database, as well as the AI functionality, and also connections to the vector database. The general use cases that the client wanted to have was an ability for users to log in and register, ask context-aware questions, similar to how in ChatGPT you can ask a follow-up and it'll know what you were talking about before, have chat session, and then have some sort of tracking of questions asked and time spent on the application. So here's kind of from a system architecture perspective what actually goes on. So you have the front end hosted on Netlify, you get a question message, you create a chat session, you check if there's an existing conversation already present. If so, we can retrieve that conversation from an SQL database to use as context when we query OpenAI. If not, we go ahead and prompt the vector database with the question. The vector database is a Pinecone server, which just has all those chunks generated from Llama index. It retrieves those relevant chunks and then comes back. Then we query GPT 3.5 with the context plus the prompt. The reason for using 3.5 versus 4 is mainly for cost savings for the client. However, I'd imagine 4 is a lot better. And then finally, we send back a response, which goes back as a chat response message on the front end. A user can continue the cycle over and over and over again with their existing context, or end the session. That data would get logged on the admin portal. So now very quickly, I'm just going to go over some of the main lessons that I learned going through this project and some of the takeaways that I took. So production is 10 times harder than development environment. So as a junior engineer, this is something I guess you realize kind of early, which is that production and getting something from a testing environment to actual use case of being able to use it is a lot harder. And there's a lot of small little things that come up, like SSL certificates, or not being able to send back and forth messages from a different IP address. Like all this stuff that just comes at you out of nowhere is not present when you just get the thing running locally, and everything's fine in local, and then you take it to production and everything goes well. Yeah, this was kind of a learning lesson that like I should be thinking about how this will actually get deployed as a actual product when I am going ahead and building these applications. I think that's something very important to learn. And again, some of these might be obvious to a lot of you that are experienced. However, these are just things that I'm learning along this journey. So the second one is probably also obvious, but it's to think about the end product and work backwards, and that will prevent repeat steps. So I'm going to give you a very simple example of that. Now, those PDFs, those 40 PDFs that are in the system need to get updated every time those PDFs and those standards change. Now that means that whole process of converting them into vectors and then storing them on a database needs to get repeated, and there needs to be a functionality for that. Now the client told me this at the end, and there was really no way for me to go back and redo it in a way that would be easily updatable, just because of how vector databases works, and since it's unstructured, it's a whole process. So like knowing this earlier, what I could have done is I could have added metadata into the vector database to actually store what the document was about, so we can just update those vectors. However, now the current situation is that you need to update all 40 of those PDFs regardless if you change one PDF. So that's a bit of a unfortunate incident. However, you should always think about the end product and work backwards to avoid things like that. Number 3 is everything is so new in the world of AI. And the reason for this is that this video where I got this essential understanding of how to do this with Llama Index was posted 3 months ago. And I had a few conversations with a lot of people across different Slack channels on like how I could go about doing this since the LangChain version was not persistent. And I was finding a lot of people were having like mixed solutions and just different things that they had put together. And so everything in this space is quite new. And so a lot of people are just trying to figure it out similar to you are. And it's not like regular full stack development where someone has done it 1,000 times before. You kind of need to go out and find the solutions yourself. And that takes a lot of time as well. And finally, is to always talk to the client and get feedback promptly. Your vision for a product is not theirs. It is better to build what they want, not what you think they want. And this is, again, like such a simple lesson, but it's a key takeaway. Because for the back end, this stuff really does not matter. However, when you're doing a front end for a client, this is something that you really want to keep in mind and also go back and forth a lot of times, because what you think that the client wants is really probably not what they want. And they probably have a different vision for it, or they like it this way, or there's just 100 different things. And it's always good to just incrementally get feedback and then build up from there, rather than just spending like 10 hours just grinding on one thing and then getting it to be perfect in your head. However, it does not look anything like what the client wants. So key lesson there. I think this goes across not just development, but every other aspect. But always get feedback incrementally and then build increment. So hopefully you found this video useful. If you did, please go ahead and leave a like. Again, helps with the YouTube algorithm. And yeah, I will continue to document cool little projects that I do, as well as the whole journey of learning all this stuff. So if you want to go ahead and subscribe to the channel, go ahead and do that. And I will see you guys in the next video.